one shows thermal conductivity and strength. And toughest material we use stainless steel 304 cold drawn type, and strength is this number. And thermal conductivity is here. And divided by thermal conductivity is 99. And when we have a number here is 1, then stainless steel is 4.5. But if we use epoxy glass fiber, I mean, like G10 type material, this is a very high number compared to the stainless steel. So usually, or you use the material, you use stainless steel, but you have to think about G10 material. It's very strong when you think about the thermal conductivity. And next one is, this is already shown. And this is a class which Cameron Honest inspired helium here. And this is the superconductivity was found with this apparatus. And then here is glass, and inside is mercury. And I think this is the heat capacity. It's 100 Kelvin here. Below 100 Kelvin, you have a very low heat capacity, almost all material. But helium is very high. So when you have something cold stuck inside the vacuum, then it is very easy to warm up because of very low heat capacity. Also the expansion and contraction. I usually use this figure, this one. When you have 300 Kelvin at this length, but when you have all the way down to 100 Kelvin, then you have a stainless steel about 3 millimeters, 1 meter length stainless steel bar is contract 3 millimeters, 0.38% of reduction. But the inbar is this is a 9% nickel iron. It's a very low thermal conduction. And Teflon is very high. Nylon, this is Araldite, is epoxy type adhesive. So when you have a crash that something like this part is gets cold, but this is still warm, then the crash that make a very defined shape and have sometimes it have a leak. And also the vacuum insulated line inside tube inside is contract very much. So you have to have some kind of bellows inside or outside. And the tensile strength is usually gets higher at the low temperature like this. Sorry, this is Japanese, but this is a nickel chrome steel. This is a GF, this is a inbound, 9% of nickel, and this is aluminum alloy duralumin, GFRP. Which one? this is the CFRP and the GFRP. And this is copper. This is annealing, nickel, chrome, steel, and aluminum, and brass and copper. But this is annealing. And those are nylon and epoxy, Teflon. And the electrical resistance is like this. Superconductivity is going down, suddenly going down to there. Copper, aluminum, and jewelry, aluminum alloy. And this is this is Constantan and Bilbao. And this is also again the craft, but this is a plastic type craft for helium, liquid helium. There is no liquid nitrogen chamber, but you have cold summer shield outside from this shield cooled by a neck through cold gas, cool this shield here, so that we have two shield. This temperature is about 30 Kelvin, and this temperature is 180 Kelvin. So that they are almost the same as this nitrogen chamber here. But we cannot use this this technique to stainless steel because too much heat from the top. This is plastic, so heat from the top is very small, so we can use this. The plastic G10 plastic craft. Usually we use the craft for AC magnet, outer current AC magnet, and squeak system. And we have to think about pressure. This one have a pressure inside, inner pressure, but vacuum chamber has a outer pressure. And here is a nitrogen chamber. Inner wall has outer pressure, but outer wall has inner pressure. And you have to calculate the strength of the wall. Usually we can use the inside of the tube chamber. You can use a thin plate because of inner pressure. But outside, when you have a thin plate and the vacuum suck the chamber to the crusher. So you have to think about that. And also when you have a leak test, helium leak test, before construct outside, put outside, you have to have a leak test only inside the chamber. But you cannot evacuate inside because of a very thin wall. It cracks. So that we need outside chamber also. Then make a helium leak test. Sometimes we have to have a chamber for the leak test. This is just transfer tube for liquid helium. Here's a leak test. This is the final shape of first this is a nitrogen chamber, liquid helium chamber, and vacuum chamber outside. But here is a welding, also maybe vertical welding, and also here is a welding. Then you have to make a helium leak test in this space. And also here is a welding part, so we have to make a leak test. Then you make this one. And this part is already leak tested. So, but when you don't have a leak test, then you have a leak here, then you cannot fix this. So you have to make a leak test on this stage. Then you make this shape and put together and make this one. Then you make a leak test of the final leak test. And this is a TIG welding. TIG welding is a welding when you weld the stainless steel, you use the TIG, tungsten nut gas welding. That's a TIG welding. And this tube is a thin, but this flange is very thick. So you have to have almost the same thickness to make a groove here, like this. Then weld here. And when you weld the tube outside, maybe if you weld here, then the flange will bend. So that in the middle, when you have a welding in the middle, then this flange cannot bend. Also, this thin wall of tube, you have to make this kind of shape for welding. And also a very thin one like this. So, to design the welding part, it is very important. Also, this kind of bellows is very thin. So this is the center, this is the front. Then you have to have welding here. But if the center is here, then the bellow is outside, you cannot weld. Because when you weld here, the center is here, then this bellows is warm up and expand and going this way. So you have a gap here. But the center is here, and then this thin tube is warm up, then going to this way. So it cannot make a gap. So very easy to weld. So never do the bellows outside, like this. This one is the center is here, and you make a welding here inside. And this is also the same I explained before. And when you weld was brazing, copper and stainless steel, and copper, you have to have a copper outside always. Because copper is shrink when you have a cold, copper is shrink more than the stainless steel. So you have to have a copper outside, always outside. This is an Indian seal. When you have a seal, like an orange seal, in the very cold parts, you cannot use orange. So you need Indian seal, and the shape is like this. This is a flange, and this is an Indian sheet or Indian wire, and many kind of technique we can use. But I like this one is best. I will finish this lecture today because we changed another part. Okay, any question?
Okay, thank you, Kamioka-san.
Yeah. Tomorrow I will give you a lecture about clavicular and heat transfer and vacuum component.
Is there any question?
I have one question. The photo on the screen, sometime
Yeah.
Gençler, umarım burada anlatılanlar anlamışsınız. Üniversite tasarımında hemen yalıtım çok önemli. Kullanılan malzemeler önemli. Bir malzemeden diğer malzemeye kaynak ya da ver dengeli o önemli. İşte malzemelerin birinin diğerinden fazla genleşmesi, büzüşmesi diye farklı olduğu için diyor ki bakır daima dışta olmaz. Dışta olursa ne olur? Fazla büzüştüğü için kopar yani. Onun gibi çok temel ayrıntılar var burada. Onun ötesinde yarınki kursumuz daha iyi olacak. Yarın bir bitmeyebilir dedi. Sorular varsa sorun tartışın. Çok kalabalık değiliz. Toplantı salonunda da devam edebiliriz. Ama yani, heat transfer konusunda you will continue about heat transfer tomorrow or will it be only prior to it? Your lecture tomorrow.
Tomorrow.
Also heat transfer or?
Yeah. Not insulation.